Alright, what's up everybody? Mr. Mir here, and we are back today with another Let's Learn in Java, specifically talking about the types of errors that we can expect to see as we go through programming. There are three types of errors when programming in Java, and they are the topics for today: syntax, runtime, logical. And let's jump into our file here, our class that we already have made. And what did I call this class? I think we went with Pirates of the Caribbean Curse of Black Pearl. Yep. So we have our class that we made, and let's talk about the three types of errors. Let's actually show off the three types of errors. The first one is the easiest one, probably: syntax errors. Now, syntax errors happen when you break the rules of programming. So something like not ending a line of code with a semicolon is a syntax error. Something like trying to store a decimal number into an int data type, syntax error. And actually, let's change the highlighting problems to only show us syntax errors so we can see things more clearly there. Not ending with semicolons, storing doubles into ints, things like that are syntax errors. There's a lot more. The nice thing about IDEs, such as IntelliJ here or Eclipse or NetBeans, are that they let us know in advance when we have syntax errors. Similar to how Microsoft Word or Google Docs lets you know when you made a spelling error or a grammar error. It underlines it in red. It kind of gives you a hint. It says required type is an int. I gave a double. So if we were to give it that, and then if we were to delete this, then it would kind of tell us, if I highlight over here, it expects a semicolon. So it tries to help you as best it can when you make a syntax error. The second type of error, so that's syntax errors, underlines in red, you broke the rules of the programming language. The second type of error is known as a runtime error. These errors aren't as nice as syntax errors because, as the name states, we actually need to run the code before they appear. But when they do appear, we're still told there is a mistake, and we're actually even told where the mistake is. As we're learning here, as we're trying to learn here, as we're starting out, we could say one of the common errors that we're going to have, or one common error that you could get with a syntax error, is if you were to divide by 0. And if we were to print this out, let's go system.out.println, we'll say num. If we were to try to run this program, we're actually going to see our arithmetic exception, as it's known. And let's actually do this. So we see an arithmetic exception when dividing by 0. It tells us right here, an arithmetic exception, division by 0 happened, and it actually tells us where it happened. We can see here our class name, and it says line 4. Your mistake is on line 4. So if I look at line 4, I can say, oh yes, that's where I divided by 0. That's where it happened. Runtime errors kind of tell us what's wrong. This is probably the most clear. Sometimes they'll just say like null pointer exception, array index out of bounds exception, and it'll try to give you a little more description over here, but it might not be as clear always as division by 0. Just keep that in mind. But it will always tell you the location. So that's one thing that is really helpful about runtime errors, is even though you have to run the program to figure out there's an error, it will tell you, hey, go look here. This is where your mistake's happening. Try to fix it. So that's really helpful with runtime errors. Our last type of error is probably the most devious one. And if you're thinking about it, it could be thought of as like Cornish pixies from like Harry Potter and the Chamber of Secrets. If you're, into that movie or you're into that series or whatever, think about it like that. They're very devious. That was really strange to say, but this is logical errors. So logical errors are really difficult to find if you make them, and you're going to make them. Everybody makes logical errors when it comes to programming at some point, because there is no official indication from Java or the IDE that there is a mistake. The way we identify logical errors is because we do not get the output we expect. We don't see a print statement we expect to see. We don't calculate the correct value, and it prints out a different value. And fixing these errors is difficult because we don't know where to begin. We don't know where to start unless we have a good design plan. And even then, it's still sometimes hard to pinpoint down logical errors and fix logical errors. So let's see a logical error on the screen here. Actually, I'm going to cut away, come back, going to have a lot more code typed on the screen, or maybe it'll get sped up, but it'll have a logical error in it. It'll actually have a couple logical errors in it. So we'll come back after that is done and we'll walk through those. Okay, so we are back with some code on the screen. And before we run here, I actually see an error in trying to show off an error, I guess. I see an error that I made. So 9 being greater than 8, and then we keep increasing 9, so it becomes 10, becomes 11, etc. should keep us in this loop forever, right? So this is a logical error. We should never leave this loop. We're in an infinite loop, 9, 10, 11, so on and so forth. So if we run this, we shouldn't see, okay, that's awkward. We do see this. Why do we see that? So here's a logical error that I made and I don't see. So much for only having a few lines of code to look at and being able to find it. So this shouldn't work. I should be in here forever. Let's actually system.out.println, see why we are leaving this. So let's stop that. So this oh wow should only execute after we've left this while loop, but if we never leave this while loop, I don't expect to see oh wow. So here's okay, so we are in the while loop for a very long time. It seems like we're in this while loop a lot longer than we were when we saw oh wow. Okay, so we're just gonna stop that and we're going to move on from that awkward moment where the logical error didn't work and it actually caused me to have a logical error. So we're just going to focus on this error then and see, hopefully this works the same way. Okay, so this one does seem to be working. There was probably something really obvious with the other one that I just didn't see, which makes this even worse. But so we have here, right, second counter is less than 10. 0 is less than 10. So we print out second counter, or we should print out second counter, and then we increase second counter by 1, and then it should be running. Right, we expect this to be running, and then I expect to see Jack Sparrow print out eventually because second counter becomes 1, becomes 2, becomes 3, so on and so forth. It will eventually become larger than 10. If I keep adding 1 to 0, it will eventually become 11. But I don't see anything, and it's been a really long time, and I still don't see anything. So this is something that often happens where you're typing code and then you go run it like this and it's just not working. Nothing's printing. You start panicking. You start worrying, oh, is my logic off here? It looks right. I mean, it's less than 10 and then I increase by 1. Why am I not seeing Jack Sparrow print out? Well, we normally end every line with a semicolon. That was one of the first things we talked about in syntax errors. However, if you have a loop or an if statement or a switch statement, you don't put a semicolon at the end of that. Right, so we have a semicolon right here at the end of our loop, which means that we are constantly running this test and we were there forever because 0 was always less than 10. It was never getting increased. That semicolon did not allow us to move on. So that semicolon right there, it's good habit. You need to have semicolons after every line, except if that line is a while loop, if statement, switch statement, for loop. There's cases where you don't have a semicolon. Right, we have a curly brace here, no semicolon before a curly brace. So now if we run this, right, we'll stop and rerun it. We should see 0 through 9, and then we see Jack Sparrow because we become 10, right? 10 is not less than itself, so that's why we break there. I said 11 earlier, but I was still thinking about why that other one didn't work. So we become 9, then we become 10, we leave, and we see Jack Sparrow. Video has run on long enough, and I'm really confused about why that first one didn't work, so I'm going to go spend some time looking into that. Oh, I wonder if it happened to overflow counter after reaching maximum number. That could happen, and that could be why that first one didn't work like I expected it to and eventually printed out what we did. Yeah, I'll have to go look at that more. But until next time, everybody, have a week.